So we're joined today by David Kennedy as part of the OHBM Oral History series. So thank you very much, David, for coming along.
Thanks for having me.
So I'd like to start by asking you about your background and why and how you became interested in neuroimaging.
Well, I was an undergraduate physics major at the University of Rochester back in the early 80s, too long ago, I'm afraid. As a physics major, I was looking for some summer work, and I ended up in the Fermi National Accelerator Laboratory chasing neutrinos around the accelerator. I noticed up on the side at Fermi Lab there was a proton therapy beam cancer center where they were using proton beams to work on interventions for cancer. Yeah. So I thought that was kind of cool, application of physics, a little bit more impactful than the oscillating neutrino. That might mean the universe is open or closed or not, which is important, but not quite on a short time scale. Cancer research cancer therapy sounded a little more interesting. I applied to be part of their fellowship program and was not accepted. But that made me start to look around for summer jobs in subsequent years around the radiology departments at the University of Rochester. And so my junior year, I hooked up with Donald Lewis, a radiologist and radiology researcher working on inventing better chest x-rays. And that was a fun engineering thing. But he was the one back in 1982 or so who said the words MRI, or probably nuclear magnetic resonance imaging back at the time, as the up-and-coming thing. And so when I graduated and looked for a graduate program, back at that time, there were 4 or so in the country that included MRI as part of their program. This was before biomedical engineering programs, so it's just could you find a applied physics type of area that had MRI as part of it. And I was fortunate enough to end up at MIT and MGH and working with Bruce Rosen, and that really got me into the neuroimaging area. That was the heyday of MRI. Things were just getting into the human clinical areas. And so everything was really possible to invent. Turn a knob, you get a new thing. And so it's just a great time and a great place to be studying neuroimaging. And that just captured me and my interests. Yeah. And then also neurology folks came along who needed applications of this. So I was able to bridge between the engineering and the physics of the imaging and the applications in clinical neurology.
Yeah. And what do you see happening with neuroimaging in the US these days?
So the way I work most is in the child psychiatry applications of neuroimaging. And in psychiatry overall, there's a little bit of a lag in terms of coming up with things that are actually making an impact on the lives of people with mental health disabilities. Certainly Tom Insel, the past head of the National Institutes of Mental Health, has lamented a lot that today a child who walks into their child psychiatrist with autism, or an adult who walks into their psychiatrist with schizophrenia, has pretty similar outcomes, pretty similar interventions than they did 30 years ago. Yeah. After a lot of imaging research, a lot of genetics research, there's still not a huge change in the outcomes. So I think that's really the focus is really how can we use these lovely technologies to really make more of an impact on those kind of areas. And so I think that's really a challenge, and really the types of way that the field is moving to try to solve either earlier diagnosis or better prognosis or better monitoring of therapy in order to improve those outcomes in ways that haven't been accomplished yet.
Yeah. And what research or other contributions are you most proud of in your career?
I so enjoyed being in the MGH environment in the heyday, in the early 80s, early 90s. While people will debate who discovered what when, certainly the MGH was near the inventions of fMRI in the first place, the contrast dynamic contrast imaging of Jack Belliveau, and then coming along with the endogenous contrast techniques. So it was just a great pleasure to be working near those folks in those areas. Then to be near Van Wedeen and the folks working on the early diffusion analysis, and then really to be through our sort of clinical and anatomic connections with Vern Cabanis and Nikos Makris, really to be able to put a anatomic framework on the cool things that the physicists were discovering. So to be near fMRIs invention to be near the diffusion invention and to sort of add our anatomic support to the implementation of those techniques. It was just really exciting.
Yeah.
In more modern eras, really trying to get to big data and data sharing. So my current work is also a lot now in informatics and data sharing. So a lot of the things we need now to solve problems require much more data than any one lab can acquire. And so I'm very proud of the work that we do in terms of data sharing and coming up with ways to try to get at bigger data problems.
Yeah. And you played a part in the creation of OHBM. What was that like, and what did you imagine OHBM would become like?
Well, to be quite honest, I was very often, an assistant, to Jack Belliveau. Jack was a remarkable visionary back in the old days, and I worked very closely with Jack. And Jack, really had the big vision of what was going on. He was, out there, meeting, Bernard Mazier, meeting Peter Fox, meeting, everyone who was doing, things. He was driven by a vision to really record consciousness,
right.
And he was quite aware that MRI, MEG, EEG, all these technologies were critical to that, and he will go up and work with anyone and to really get deep into those things. Mm-hmm. So that early vision of fMRI being important, the early meetings, and Jack really insisting that OHBM have its second annual meeting in Boston, and that it not just be an annual meeting, but it actually be a society. Mm-hmm. So following and supporting Jack's vision, Bruce Rose and Jack and I were able to really begin a framework that it supported the meeting in Boston in 1996, but we put into place a framework that could move forward and then be adoptable by the community. So it was a great opportunity to sort of set that in motion in hopes that it would propel the field. We had our to overcome some of the old school people at the time who were kind of embedded in more cerebral blood flow types of things. They had to be convinced that this MRI thing was real. Mm-hmm. So it took a little bit of work, and eventually we were able to convince the PET people and the tracer people that this is a real thing and it's worth pursuing. And so that was just great to be able to support the development of that and really launch that so that it could move forward.
Yeah. And so what have you found the most rewarding about your involvement with OHBM over the years?
Oh, its breadth of people who are interested in so many different things. Yes, it started out as brain mapping, and you had a MRI centric focus, but from the beginning it was MEG and EEG and PET, and just a very broad set of types of observations, and a very international and quite frankly fairly young in the day group. It's very dynamic. So that was always great to get such an international, such a diverse group of people together.
Yeah. And what memories stand out when you think about your experiences attending OHBM?
Oh, playing frisbee at 3 a.m. in a lobby of a hotel in Copenhagen. And in 1996, the town meeting was really quite a remarkable event. I know if you talk to Alan Evans, you may hear a little bit about that from his point of view, being the one standing up. He did wear a pith helmet that I was fortunate to hold for him for many years. That pith helmet shows up, I think, on the honor of the 25th anniversary, or some anniversary. I had been in possession of that helmet for a long time, so I was able to present it back to him. So
we heard your wife tried to throw it out. That she found the helmet and wanted to get rid of it.
Yes, that is true. My wife was not thrilled with the helmet being there, but it survived many years, and I was very pleased eventually to give it back after Alan kind of insisted that I give it back.
And what changes have you seen in OHBM over the years?
Well, there's been many changes, but the one I'm worked a lot with is the Open Science Special Interest Group. That's very exciting. It's another place where a lot of the young, really excited, investigators are. That's an area where, maybe a lot of the physics has been, worked out. So where is the place to make a lot of progress? I think software, data sharing, the new processing that you can do with these larger data sets is really an important area. So the youth and the vibrancy of the folks who are playing around in the open science area is very encouraging. So that's the type of thing I think is really great opportunity to develop more things and to get new techniques developed and to capture the energy and the skills that today's young scientists and programmers are bringing to the field.
Great. And what do you see as the future of neuroimaging then?
The future of neuroimaging, I'm often motivated by some of the things I've heard Randy Buckner speak about recently, is really trying to get to personalized observation and really sort of temporally meaningful observations. The time of looking at disease versus not disease, maybe passing a little bit, and you really want to understand within a disease, your good days and your bad days, your high anxiety moments and your low anxiety moments. What are the neural signatures of that? Be it fMRI, be it EEG, be it MEG. Can we really get these dynamic signatures, which are really much more relevant to what you might then be able to intervene with through therapies, through medical interventions. So I think that's really getting to the point where we can personalize and temporalize in a way that's meaningful.
David, thank you very much for your time.
Sure thing. Thanks for having me.